All right, algebra. This is a video walking through the rest of your 11, 4, 5, 6 worksheet, really focusing on 11, 5, 11, 6. This is actually number 8 on 11, 5. And then I just go through one by one, going through the problems that we didn't really cover in class. All right, and I want to make sure, just even before this, anytime I make a video, you guys, it does you no good to go through and copy all the answers. So please take your time to listen to what I'm saying, go through it with me, and I really think that will benefit you the most. All right, so let's take advantage of that. There's like 2 of me in the classroom to help you out, right, in that sense. So one, as you're watching the video, and also to be able to ask questions. Now, this is going to be on YouTube, so you can always go back and watch it again later and make sure you understand these things as you're preparing for your test next week. So number 8 here, we are looking at solving this, and I'm always, most often in this situation, I'm doing some kind of long division. So you have the 7m squared. I'm going to rewrite this in standard form, but I also want to always think through, could I factor this thing in a simple, easier way with this as one of my factors? Okay, now, as we solve this one, you're going to see this actually, m-1 actually goes into this really nicely. But I don't think it's really obvious on the surface. And what I would say, again, is you want to take one that's easy to factor on the surface, that you like just know right away. Those are the ones you want to do that way. If this is a little more detailed, this is one that you have to do factoring by grouping, then maybe you would want to go through long division, because I don't think it's going to take you that much shorter of an amount of time, unless it's really obvious how this would break down. So I'm going to go through this the long way, long division way, and I always start by asking myself, what do I multiply m by to get 7m squared? And that would be 7m. Right, I'm going to multiply this here to get 7m squared. I'm also going to multiply this here, kind of like, again, the distributive property, and I'm going to get negative 7m. What we do next to kind of cancel these out is we're going to subtract both of these. So I end up with, these are going to cancel out, and then I end up with 2m minus 2. Then I ask myself again, what do I multiply this by to get 2m? And that's going to be a positive 2. We do the same thing, kind of like distributive property, right? So we got 2m. 2 times negative 1 is negative 2. When you get this is really good because you're going to, again, add a line, change the sign kind of here. These are both going to cancel out, and I get a remainder of 0. So my final answer is 7m plus 2. Okay? When you take 7m squared minus 2 minus 5m, you divide it by m minus 1, you end up with 7m plus 2. I don't know that I've explained how to check any of these, so just really briefly, I want to make sure you guys see this. If I took these two things and I FOILed or did the distributive property, right, I would end up with 7m squared minus 5m minus 2. And again, you can see that really quickly if you start to multiply these out. I'm going to leave that to you guys to do if you're interested. But you can always double check these, like that you got the right answer, right? That you distributive property, you get the same thing. All right? Number 9. Again, same question I would ask, is there a way for me to figure out a shorter version of this? If not, again, I'm going to jump straight to long division. What do I have to multiply 2x by to get 8x squared? That would be 4x. It's going to be 8x squared if I multiply these two. If I multiply these two, I'm going to get minus 12x. All right. Change my signs. I'm going to subtract here. So you got 6x. Bring this guy down here, plus 2. All right, and to get 6x, I would multiply by, again, I'm going to ask, what do I multiply 2x by to get 6x? I'm going to multiply by 3. Multiply that out, I get 6x minus 9. Add a line, change the sign. These cancel out. I have a value of 11 left over, a remainder. Whenever we get to a number, notice there's x's here, there's x's here. Oh, no more x's. When I get to that step, this is my remainder. So my final answer becomes 4x plus 3 plus 11. That's my remainder over 2x minus 3. Because all along the way, I've been asking, what do I have to multiply this by to get this? Or what is 8x squared divided by 2x? Well, that's 4x, right? And so I'm dividing all along the way, and I can't break this one down anymore, so I have to write it as a fraction. Number 10. Again, this one's not written in standard form, so that would be my first step, 8t squared plus 2t minus 5. Notice I just keep my signs that 8t is positive, the 2t is positive, we didn't write it, but positive, and then the negative here. So I kept my signs the same. Move these guys over. Just erase those. Right? And then 4t minus 3. Same questions, again, over and over, so you're getting the habit of it. What do I multiply 4t by to get 8t squared? Or, what is 8t squared divided by 4t? What cancels out with those two? So I end up with 2t. Yeah, 2t squared minus 6t. I do distributive property to both of those values. So you got the this should say 8. 8t, 2t times 4t is 8t squared. And then 2t times negative 3 is negative 6t. Okay, we're going to subtract these values, so these are going to cancel out. And I end up with 8t, bring down my 5, minus 5. What do I multiply 4t by to get 8t? Or what is 8t divided by 4t? That would be plus 2. 8t, and 2 times 3 is, negative 3 is negative 6. All right. We're going to subtract these, and I end up with a remainder of 1. So, my answer, 2t, that was terrible. 2, still terrible. One more time. 2t plus 2 with a remainder of 1 over 4t minus 3. Final answer. All right. All right. Number 12. So this one. This is one that I would really hope at this point that this looks really familiar to you. Okay, maybe I won't do it this way. Let's blow it up. Make it bigger here. Right? This is something you guys should be very familiar with, and I want to make sure as much as possible that we recognize that this is a perfect square. Sorry, not a perfect square. It's like a perfect square. It's a difference of squares, meaning we've seen this where you have a perfect square here, and a perfect square here, and the negative sign between them always ends up working out to this really nice, like, p plus 4, p minus 4, and they're asking you to divide that by this guy, right? So divide that by p minus 4. So this becomes this guy, and then on the bottom, p minus 4. And so the idea is, this one is really easily determined. If you catch that this is a perfect square, and this is a perfect square, and there's a negative between them, that this is actually what we call a difference of squares. You have these two things. One's a positive, one's a negative. That's the idea, right? That what we can do is simply write it this way and then cancel these out. Really simple. Okay, so my final answer is just that leftover p plus 4. Again, that's all assuming that you recognize that this right here, p squared minus 16, perfect square, negative between them, breaks down this way. Okay? And we've seen a lot of those, so hopefully that's kind of clicking a little bit quicker on these problems. Okay? This one, is not that way. I look at it really quick and I'm like, 14, man, that's not a perfect square as much as I might want it to be. So on this one, I would have to do some long division. And there's no q, right? It goes from q squared and then all of a sudden it's just plus 14. So I have to add a 0q plus 14. Okay. I notice I didn't do that here because it didn't matter. I recognize this is actually factorable, and I broke it down. Okay, I'm doing this here because this is not factorable, and my q right in the middle here is missing, and so I have to add it. And this is just a 0 because there's none of them here, and you have q plus 7. All right, and then I just proceed like I've been doing. Hey, take q squared divided by q, or what do you multiply q by to get q squared? That's q. So you have q squared plus, when I multiply this one out, q times 7, I get 7q. All right, and I'm going to change my signs here. Add those together. These are going to cancel out, and I end up with negative 7q plus 14. I'm then going to ask myself, what do I multiply negative 7q by? Okay. I multiply negative 7q by to get q. Or sorry, I said that backwards. What do I multiply q by to get negative 7q? And that's going to be negative 7. Okay. So I end up with this, multiply negative 7q and then minus 49. Really large negative number here. Distribute these through. Negative 7 times 49. Okay. I'm going to change my signs here. These are going to cancel out. And then over here, again, I have a really large remainder of 63. Okay. So my final answer, you take this guy here, q minus 7 plus 63 over q plus 7. Okay. So something like this, again, a little bit longer, a little bit more information, in terms of you can see how nice this one is comparatively to having to break this down. All right, so the next one here, number 14, it looks like a big mess. There's a lot going on, and I would say this is not the easiest problem we've done, but when you're finding volume is simply like of a rectangular prism, is length times width times height, right? They want us to basically write the height in terms of x. Now think carefully, what we've been doing is dividing polynomials, right? So I know there's going to be some division here in this problem. But what they're saying is if I took these values, x plus 2 times x plus 5, and I multiply that by the height, this is, let's undo that last part, x plus 5 times the height, okay, that should give me this like really long guy, x cubed plus 5x squared minus 4x minus 20. Okay, and they want me, again, write the expression for height. So what they're asking me to do is like to solve for h. So I'm going to divide by x plus 2 and x plus 5. I'm going to divide this guy by x plus 2 and x plus 5. Okay. Again, so like these are going to cancel out. So what's left over on the left is h, and then on the right is this big like ugly, that blob. Okay. So we haven't done a ton of problems that look like this top one, but I wanted to walk through this. So kind of as a side, we're gonna deal with this guy first on the top here. We wanna think about him. So we're gonna come over here. We've got x to the third plus 5x minus 5x squared minus 4x minus 20. I think if I got all that right, I just want to double check. Yeah. Okay, so we're going to look at this. Now, in order to break this down, one method, there's a couple, one method is to group things together. Is to ask yourself, like, if I put these together, because they have a lot in common there, they've got a lot of x's, and I put, these two together, can I figure out a common value, something that would help me in both of these. So if I look at these guys, I could factor out an x squared. Both of them have an x squared. And what I would be left with, if I divide this by x squared and this by x squared, is x plus 5. Hopefully we see that, right? X to the third divided by x squared is just x, right? Or multiply these back together, you get x to the third. And then 5 times x squared is 5x squared. Similarly, on these two, they both have a negative, and they're both divisible by 4, right? So 4x is divisible by 4, and 20 is divisible by 4. So 4x, negative 4x divided by 4 is x. Negative 20 divided by negative 4 is positive 5. And hopefully you guys, this looks familiar. Notice these are the same. Whenever those are the same, we can, try that again, we can write those as a factor, x plus 5, and then the leftover stuff, this guy here and this guy here, maybe I will just focus on those here, we'll circle those in orange for us, become this thing over here, x squared minus 4. Well, even this, we talked about just a minute ago, when you have a perfect square minus a perfect square, actually becomes x plus 2, square root of 4 is 2, and x minus 2 times x plus 5. So that big thing that we started off with just a minute ago, this guy, has now become this. Now, why is that important? Because the original problem, if I take this over here, I've got x plus 5 times x plus 2 times x minus 2. And we were dividing that by something. We were actually dividing it by x plus 2 and x plus 5. And notice this, look how beautiful this is, right? What's going to happen is, as I do all that, these two are going to cancel out. Okay, watch as I do it, right? This one, x plus 5 and x plus 5 on the bottom, those cancel each other out, equals 1. X plus 2 and x plus 2, those are going to cancel each other out. And I am left with my answer, x minus 2. Okay? So all of that, all that big mess up here ended up just boiling down to this. So that tells me that my height is actually equal to x minus 2. Again, this is a little bit more in depth because of that, but it breaks down really nicely, as I've tried to remind you on all the problems. When they give you things that even look really ugly, they're meaning them to break down pretty simply. Okay? All right. This is now 11.6. 11.6, they were asking us on number 10 here to find a LCD, least common denominator, between these two. All right. Technically, the denominator of this is currently 1. So least common denominator would be u. All right. U goes into u, and 1 goes into u. Well, that was the LCD of that one. I just thought it's interesting because this one, a lot of times students look at it and they're like, well, this already has a u, but it's not in the denominator. So you need to have the common denominator. Okay. Then all of a sudden, at 12 and following the rest of the page, really, what they're doing is now they're asking you to combine them. So I look at this and I'm like, do these have a common denominator? The answer is no. Okay, again, this is number 12, but what I'm going to do is I just want to get rid of this to give us some space to write things. My LCD at the very outset, I want to make sure I acknowledge the LCD is going to be 21y. Okay, it's 21y because these both have a y already. So that's great, so I need a y. And then 3 and 7, the only number they both go into is actually 3 times 7, which is 21. Okay, the lowest number they go into. So in order to get this guy on the left, in order to get 3y to be the same as 21y, I have to multiply it by 7 over 7. Right? I'm going to multiply it by 1. This is a fancy way of writing 1. So that when I multiply, again, the bottom is going to become 21y, and the top will become distributive property 7y minus 14. Okay. My other fraction over here, to get this to become 21, I have to multiply by 3, and I'm going to do again 3 over 3. So I have plus 21y, and then distributive property here also. You've got 9y plus 6. Again, when you do this, really the bottom doesn't matter anymore. Now that they're the same, you're going to do 21y, and you're combining the top, just making sure you put together all the like terms. So 9y plus 7y is 16y. And negative 14 plus 6, again, I'm taking these two. No y's here, so like terms. I'm adding those or subtracting those, that's negative 8. Okay? And I always ask myself if there's something I could do to reduce. Okay? On the top here, these are both divisible by 8. So I'm going to try to simplify that. You would have 8, 2y minus 8, minus 1. Minus 1 over 21y. That's as far as I can break it down. I can't break down the 8 and the 21, right? Those are not reducible in any way. There, you can't simplify them. So this would be your final answer. Okay. Always breaking down all along the way as much as we can. All right. This one, number 13. Again, let's bring this down. Let's give ourselves a little room to work here. Number 13. Least common denominator, LCD. It gets always helpful to acknowledge what it is. Smallest number that 10t and 4t go into would be 20. They already have the t, but I need to get them to be 20, right? So on the left, I'd have to multiply this by 2 over 2, all right? Which is going to give me a value of 20t over, that's on the denominator, and then 2t plus 10. All right, on the right side here, we're going to multiply both by the top and bottom by 5, right? Again, I want this to be 20t, so 4t times 5 will give me 20t. So 20t, and then on the top, distributive property, 5t minus 10. So I multiply that out. Add that to get together. Again, this is an addition problem. So the denominators stay the same. Combining any like terms I have, I've got 7t, 17, right? My 10s are going to cancel out, right? So you got 10 minus 10. And this is reducible, right? Or simplifiable. That's a terrible way to say that. I could simplify this. All right, my t's are going to cancel out. So I end up with just 7 over 10. That would be my final answer here. And always asking at the very end, can I reduce in some way, shape, or form? All right. Number 14. Number 14. This one, I want to remind us, this is a fraction. It's over 1, and there's no denominator there. So the LCD, I guess there is a denominator. The denominator is 1. There's nothing written. Okay, the LCD is going to be h minus 3. So I'm going to multiply h minus 3 over h minus 3. Okay. This is a fancy way, again, of writing 1, just like we did on all the other ones. It just looks longer. So on the left, this is really the one that matters because this is already with that denominator. I have 4h minus 12 over h minus 3. And then subtract or minus from the original h plus 3 over h minus 3. And again, I want us to be really careful on this one. This negative counts for both of these guys. It gets distributed through. So we just want to be careful about that it gets to both of those. All right. And so as we solve that, we're going to end up with 3h. Okay, 4h minus h, and then negative 12 minus 3 is negative 15. Okay, again, negative 12 right here, negative 12 minus 3 equals negative. I just want you to see how we get that, and then this is over h minus 3. Okay, the top I could simplify. There's a 3 goes into both of those, so I have 3h minus 5 over h minus 3. And that would be my final answer. All right? So you break it down again as much as you can, simplify, and you get your answer. All right, number 15 is a little different. There's a little subtlety to here, and it's really hidden in these two things. We've talked about this briefly more in other places, but on this one I wanted to point it out because it makes this one a lot simpler. Okay, and that is that if I take this guy right here, this thing 6 minus q, if I took this and I factored out a -1, I factored out a -1, then this would now become a negative, and this would become a positive. And I could rewrite this. I got -1. If I rewrote this part, I would have q minus 6. And so you can see this is actually the same as this. It's just multiplied by -1. So if I took the left side, I could rewrite it. It would be this 3q over -1 times q minus 6. And that -1, I could easily put it on the top or the bottom. Or I could say, let me multiply by -1 over -1. This -1 will cancel out. It'll be equal to +1. And the negative will just now come up here. Like -1 times all that. So this problem actually, if you know this, is a lot simpler. You have -3q over q minus 6 plus 8 over q minus 6, which now becomes -3q plus 8 over q minus 6. And you're done. Okay? You don't have to go through all of this every time. It's recognizing that this times -1 is the same as this. And so you take that -1 and you're going to move it to the top. So there's a short way to do it. All right? That's number 15. And then the last one, number 16 here. What we're looking at is a distance and time and rate problem, right? So they want the total number of time. So if you think of time, it's equal to distance divided by rate or speed. So we actually have 2 times, right? The time there and the time back. So what I have here is an addition problem. I want total time. So I'm going to add 2 fractions together. The distance for the first one is 15 miles over my speed, which my speed was x miles per hour, I'll say with the current. So notice the current is traveling 3 miles per hour. So if I'm in my boat traveling this way, the current of the water is helping me. But on the way back, whatever my speed was, if I'm going against the current, it's the opposite. It's a subtraction. So we've got these 2 things, and we are doing LCD. So the LCD of these 2 things, least common denominator, is x plus 3 times x minus 3, right? There's nothing these have in common. This is not like the last one, where if I take out a negative, I get the same thing, okay? So I can't do that, but so I just multiply them together, all right? X minus 3 is needed over here, and then x plus 3 is needed over here. Then they would be the same. So I end up doing all this, so you multiply out, okay? So on the top I have, try to separate that. On the top of the left here, I've got 15x minus 45 over x plus 3, x minus 3. Plus, on the left side, 15x plus 45 over x plus 3, x minus 3. Right? And the top, as I start to add them together, it's really nice. My 45s are going to cancel out, and I'm left with 30x over x plus 3, x minus 3. And I would just leave my answer like that. Okay? So it's really this one, more than anything, I feel like the actual math part is not too hard. It's recognizing that as you're solving this one, you really needed to think through distance equals rate times time, or time equals distance divided by rate to really solve that. Well, hopefully that's helpful. And again, you can go through and go back and focus on the ones you need. But if you have any questions, don't hesitate to ask, and I can help you out more.